Hey guys, in this new tutorial for this month, we're going to be covering some of the new height field scattering tools and options with Redshift, and also the new packed primitive options that we have. And so, in the past, if you guys have seen my other scattering tutorials, what we need is actually to use the instancer node, and we basically had scatter points with our height field scatter and then feed that data into the instancer system, and then we had to write custom attributes, and basically it was a lot more work. And recently in Houdini 17, they updated the height field scatter system. They made it way better, and also recently Redshift updated to support the packed primitive instancing. So the copy SOP workflow that people that use Mantra are used to, and that opened up a lot of doors and made things a lot easier. And so we're gonna work on this terrain that I've got. And this tutorial is just going to cover the scattering, I think. So if you check it out right now, I just have a pretty basic height field terrain from the shelf that I just modified. It's not even high quality because we're going to cover it with a lot of trees. Just a HOSEC model physical sun sky, which is, if you guys don't know, if you're not on the latest version, the new physical sun sky, if you go under the shader, there's Pretham and HOSEC Wilkie. HOSEC Wilkie, right now it's still stuck on Pretham for the default, because I think if they change it in Houdini, it'll break backwards compatibility. So Fuengo, the dev for Houdini, is checking into this because I requested that HOSEC should be the default because it just looks way better. So if you guys are using the new version and you need to use a physical sun sky, definitely use HOSEC. I'll actually give you guys a little comparison right now so you guys can see the difference. So right now I also have some VDBs of some clouds laid out. They're not visible, I just have them as boxes so that the viewport stays light. So if we check out my render, this is what we've got right now. And the terrain isn't anything fancy, like I said. Right now the clouds and the sky is what looks good. And there's just a couple cloud VDBs, and they're just rotated and scaled and stuff. And then we have a giant, actually this should be my fog, I believe. Yeah, so then I have a giant fog. Let's just rename this to our atmosphere. I prefer using a big VDB cube to give the sense of atmospheric depth, so that when you get some nice blue in the distance. And I'm not using any post effects or anything like that. This is just a raw render, because I'm using a non-post effect build since all these new things got added. So the post effects builds haven't merged into the standard builds yet, so just can't, we're just not gonna use them, because the new packed primitive stuff and the new HOSEC Wilkie sky model is just way better. And so they also updated the volume shader. So this is why it's even easier now to get some really sweet looking clouds. If we come in here and they're all using the same shader, by the way. It's just one shader I made. We can now control our scattering absorption colors. So you can actually ramp them, or if you have VDB data, you can add them in here into the channel data. I just made custom ramps and adjusted these. I think next month I'll probably go over how to make a nice cloud shader, just because a lot of people seem to ask about that and have trouble doing it. And now that we've got these updated volume controls, I'll probably go over this and how to use that in a cloud. And Yeah, it makes a big difference. We still aren't going to get the same quality as you can in like Arnold or Mantra. The only reason being is that we're still missing volume noise and displacement, which adds that extra render time detail. And we're also still missing multi-scatter, which is really important to get the nice details inside there. But it still looks really good. I mean, this is still really good. And it's fast. You know, this took 57 seconds to render. And just to show you guys an example, a difference between the Hosek Sky model and Pritham, I'm going to just save this. And I'm going to render the same scene, same sun location and everything. No changes. The only change I'm going to make is I'm going to use a different model here. So let's just switch over to Pritham and let's render this out. And while that's rendering, it's just, oops, oh no, what did I do? I accidentally clicked something. Let's switch over. There we go. So this should be using, yeah, there we go. So let that render for a second so you guys can see the difference. Pritham is it's a good model, but it's older. It looks a little different. I prefer Hosek Wilkie. It just looks a lot more realistic, and pretty much every engine now uses Hosek. But it's cool that we have the option now. And I asked for Hosek Wilkie. That's one of the features I asked for a long time. So it's great to see it finally added, because it really makes a big difference in the quality of light that the physical sun gives. It just looks way more realistic, and the colors and stuff, the atmosphere, everything just looks better. So and the light intensities. Alright, so this is pretty much done. So here is the Pritham model versus the Hosek model. The Hosek model, the sky and the gradients and the light intensity are they're just way better. So if you guys don't know this, just letting you know now, stick to the Hosek Wilkie model. And so yeah, for now we're going to just focus on scattering on this terrain. And like I said, it's nothing particularly fancy. It is literally just, and actually, there we go. I think I wrote it out. Yeah, so I wrote it out. Let's just move the camera around now. So this is all it is. It's literally, I just came up to the shelf, and I think I picked Canyon, maybe, or Valley. I don't know. I picked one of these, and then I just came in here and adjusted it at just messed around with the noise and stuff like that. And then eventually I did an erosion, and actually I should cancel that because it's going to try to cook it right now, and I don't want that. And after we eroded it, I wrote it out as a cache. You guys should know already how to do this if you saw the other environment tutorial. Like I said, it's not really that detailed. It's actually kind of low res, not really great looking. And the reason why is because we're going to cover it with plants anyways. And if you're actually wondering where I got the idea from, for reference, over the Thanksgiving weekend, I was driving up the 101 coast, and so I took a picture, and so this is kind of what I'm going for. So if we compare where we're at, this is my reference image. So I use this to kind of get the look of the clouds and the sky that I wanted. Obviously this is going to have more contrast and stuff, but our goal for this tutorial is going to be to scatter. Now that we've got the sky looking pretty similar, and we've got maybe we might have to adjust the volume atmosphere to be stronger once we get our assets on here, and we've got the shadows and stuff from the clouds. Our next step is going to be to try and scatter some trees and get this variation that we've got going, where from the looks of it, some of the larger trees have a different type of smaller tree growing next to them and stuff. So we're gonna go over some of the new scatter tools in the height field system that make this type of natural ecosystem scattering really easy. And if you guys are coming from Maya in the last couple of years, you'll know that MASH has ecosystem scatter, which is really great and easy to use. But the Maya system, I think, isn't as flexible as the Houdini one. And in Houdini 17, when they added this it's amazing. So we'll be going over that, and we'll start out by just trying to scatter boxes, and then eventually we'll replace the boxes with our own actual tree assets that we'll make in SpeedTree that we have already pre-made and stuff from my library. And so what we're going to try to do is start with boxes, get the variation amount down. So as you can see, most of the trees or the foliage is this type, and then we have some of the larger trees, and then a smaller percentage of these larger trees are yellowy. And so we're going to try to get this type of density and clustering of trees, that look, eventually. And so in order to do that, we're going to have to learn how to use the new height field scatter stuff. And so we're going to move that out of the way. And basically, we're going to just use this terrain, this simple terrain, as a base to scatter on. And so all we did was we made some masks to use to then feed into our visualize. So we use sediment, debris, our slope. And the slope I made using the mask by feature. And then I just changed the name with a copy layer from mask to slope. Then I cleared the mask, so the mask is gone. And we used the height field visualize to make our own custom ramps. And then we converted that into polygons. And I eventually did a poly reduce. So if we come in here, the density is 1.5. And we use the bake point colors, and so what that gives us is the color CD attribute. So if we middle mouse click here, we should have CD right here, and so that's actually what's giving us our material. If we come into terrain, we're using the Redshift user data color CD, and that's controlling our diffuse material, and so that's why in our render we're getting those colors right here. And this is just for filler. Like I said, there's going to be stuff covering most of this, but at least that way, if you can see between gaps of trees, we'll have some variation. And yeah, let's dive back in here. And so here we've got, once again, our convert height field, and I just ran it through a poly reduce to reduce the polygon count, and I wrote it out as a file. So actually what we're going to do now is we're going to split the file out into its own object, so that way we don't get all confused with all the other nodes that are in here, since we're not going to deal with any of this until we get to here where we're going to start to scatter, and we're going to branch off and go our own way. And so let's call this terrain geo, and we're going to come in here and cut this. And actually, let's cancel that because we don't want a poly reduce either. We just want the visualize. And we're going to unhook this for now. We'll just move this off to the side because we're not converting it anymore. but we'll keep it in case we decide to resimulate or anything and reconvert. But for now, we're going to unhook it. And inside of here, we're going to delete this, and we'll just paste this in. And so now we've got our polygon mesh with all our color per vertex data, and it's good to go. And of course we could pack this if we wanted, or for the viewport, but the viewport's already pretty light, and so I don't think we'll have to deal with that. And actually, let's save this out, so just as a new version before I keep editing. So we'll come up here and we'll save as, and we'll call this number 2. Oops. And we'll just save this as number 2. So in here, we actually are going to keep this on. Redshift won't render this because it's just height field data. It's not geometry anymore. But because we separated it, this is actually geometry. And so this will render now. But what we're going to keep this for now is we're actually going to scatter on top of this. And so for our next step, we're going to, I think, let's look at the reference. Let's see. It's just, there's, overall, I'd say there's about the large cluster. There's about 3 different large trees. There's these more reddish, a little more yellowish, and this greenish. So we'll make 3 variations of boxes, and then we'll have 2 versions of these smaller boxes. So 5 assets total is what we're going to scatter on here. I think that should be enough. So what we're going to do now is we're going to make a new what do they call these again? Network box. And this is just for organizing stuff, makes it easier. And we'll just drop down a box. And these are just placeholders. We're going to end up replacing these, but it's so we can easily visualize our scatter while we work on it before we actually replace these with trees. It's just better to work this way so you can see what you're doing. And we're going to dive in here, drop down to normal, and let's actually zoom in on this little box. And for right now, it's cut halfway through, so there's a little trick with the transform node. I'm sure some of you guys have seen this, where you just translate by half the height, and so now it's on the surface rather than halfway beneath in negative space. And we'll just make a material. Right now we don't have any material, so let's go into our material editor, and these will just be placeholders. So we'll just make Redshift material, and we need 5 of these. And just for visualization purposes, we'll come in here and we'll just say these bigger trees will be a bright green. The fall looking trees will be like a yellow. And then the final trees will be more of a brown. So that way we can tell which ones are which. And then these smaller bushes will just make like a dirtier green. And an even darker green. And so that'll just give us an idea of how the variation shapes are being formed. And so let's get back in here, back to our box. And these boxes are going to be a little bit bigger than the smaller boxes, so we'll just make this let's see if we look at the reference again. I'm going to just assume that, I don't know, it looks like it's 5 times bigger. So we'll just say 5. That might be too big. Yeah. Let's just say 3. And we could always adjust that later. And for our material, we'll throw in material 1. And we're going to just duplicate this 5 times. And box 5, material 5. For our scale transform, we're going to keep that at 1. And for this one again, this will be material 4. Scale of 1. Let's dive back out. This will be material 3. Material 2. Yeah, so cool. So eventually, once we bring in our tree assets, we're going to replace these boxes with the actual trees. But right now, I think this will make it easier for you guys to see and understand how this system works. And it also makes it easier to visualize once it's scattered on here, kind of what's happening. And so for next step, we're going to dive into our terrain. And now that we've got this visualize selected, what we want to do is we want to actually start scattering on this. But instead of just scattering across the entire thing, which could be slow, because it depends, you know, this terrain's pretty big, so it might scatter hundreds of thousands of points. We don't know. We're going to actually make a mask based on slopes, because if you look at the reference, there are spots, particularly very steep angles, if you look around, where our trees do not grow. But in general, they're almost everywhere. But there are little areas where they are not growing. So we're going to actually start with a height field mask. So if you hit tab and type HF and mask, HF is short for height field, you'll get the different mask options. We're going to do mask by feature. Connect this in. We're going to highlight this. And so right now it's masking by slope. And actually, instead of visualizing, we're going to kill our visualize. Or actually, no. Let's duplicate this. And we'll get rid of everything. And that way we can just keep it one color. And we'll make this one color black, I suppose. or remove material actually might be easier. Yeah, and we'll just remove the material. And we'll keep this to the side. And this just will help us see where the mask is. So if we look through our camera view, you'll notice that right now there's a lot of areas where our mask is actually not going in. So what we want, and let's just move this further to the side. Keep this there. So what we want is we actually want more trees, basically. So we're going to change the slope angle. So the minimum slope angle is lower. I mean, 0 should technically be fine because we want things to be scattered on a flat ground. But very steep angles, maybe 60 degrees. And just to add some variation in here, actually we'll increase this. So maybe see what 10 gets. No, 10's too much. Let's try 5. And so this will give us some variation that we need. And we'll be scattering in a bunch of areas, but the very steep angles will not be scattered upon. And so let's look back through our camera, and you could add noise to this also. Maybe we'll do that. Let's HF mask, and you can also blur it. There's a bunch of options you can have here. Try noise. And let's see if we could subtract it. No, that's too much. Let's disable it and just see what our noise looks like on its own. So right now our noise pattern's really big. So let's amplitude, let's try amplitude 2. So it's a little sharper, and our element size is way too big. Let's shrink that down. That's still too big. Let's try 10. That's a little better. There's different noise styles. You could try cellular, and this actually might be better because it gives us a little bit of breakup. So let's reintroduce our mask, but instead of additive, we're going to go subtractive, and that might still be too much. So let's try 5, 3. That might be pretty good right there. Let's see. Yeah. So this we don't get it in the high slopes. And maybe we'll increase the slope breakup just a little bit lower. Let's try 55. Let's look through. Huh. That's weird. Yeah, let's try 55. And let's do that. And that'll just give us a little bit of variation in there to kind of break things apart a little bit. Okay, cool. So now we've got this masked out, and we could start to scatter stuff on here. So if we type in HF scatter, we'll get the new scatter SOP. And so this has been around since I think Houdini 16, but they updated it in 17 and really stepped it up. So it's got a lot more controls now, and you can layer it hierarchically. So I'll explain what that means later, but how it works, you can adjust the rotations, the randomization of scaling, all that stuff here. This node will do all that stuff for you now, so you don't have to go in there and create, make an attribute create or an attribute random, like a attribute randomize, and type in p scale or whatever. We don't have to do that anymore. It's good to know that though, guys, so I still recommend watch the other tutorials so you know how to work with those attributes, but this just makes life a lot easier. And so if we come up here and plug this in, this is probably going to create a ton of points. And let's come up here. You might not be able to actually see them that well. Let's actually, I think what's causing a problem is that the terrain geometry is being visualized. So let's hide this for now. Our polygon mesh, let's hide that because we don't really care about that right now. And we're scattering points. So if you zoom in here, you'll see the points. They're around, but it's and it's all inside of our mask. So if we, and actually let's see here. Let's instead of calling it mask, let's use a different name because it's getting in the way, the red color. So let's move this down and let's hit in HF property, or no, actually HF copy layer, and let's unhook this, plug this in, connect this, and we're going to take our masks, which is this height field data, this mask that we made, and we're going to call this let's call it big trees scatter, because that's what this is going to be. Our first height field is just going to be for the big trees. And I'll explain why once we start putting stuff together. And we're going to hook that back in, but now instead of using mask, we're actually going to mask this in using our big tree scatter. And let's actually, again, let's clear our mask so that way it's not getting in the way. So if we highlight this, now it's back to just being white. And we'll highlight this, and now you'll notice that there's these points. All these little tiny points everywhere. And so that is our scattered points. And you'll notice that the way they're working is based on our mask we just created. So there aren't any points down here. If we come up to the cliff, there's not that many points here, and so on. And we should probably actually make the points bigger because they're kind of hard to see. So in order to do that, just for visualization purposes, if you hit the D key, this will pull up the display options where you could adjust all types of stuff. And under geometry, you could control tessellation, wireframe, point instancing percentages, stand-in geometry, all that stuff. And what we want to change here is our points. Right now they're too small, so we're gonna just make this pretty big. That might actually be too big. Let's try, I think 10's okay. And so if we look around, you can kind of get an idea of where our scatters are. And so if we look back through our camera, you can kind of get an idea of where things are going to be scattered. And right now there's actually not that many down here. So let's come up and adjust that. So in our mask by feature, let's actually drop our minimum. Let's try 3. Give that a second to cook. And no, let's drop that to 1. And let's move our blur ramp. So 0.2. Let's move it in. And let's just try 0.1. And that should give us, yeah, that's a good amount of scattered assets. We might be a little too close, but to the ground, but we'll see. And from here, let's change that out again. I'll drop this down this way. And we'll keep this at 5. And I think our smoothing radius is fine. So let's jump back up to our scatter. So what we want to do is we want to put some of the trees in here. But the problem is, if we zoom out, most of them are not the larger trees. I mean, they're around, but the vast majority is the smaller bushes. And so what the new features in the height field scatter system let you do is, with a hierarchy, you can control, let's say if you add another height field scatter here, you can have them grow around based on your original scatter. So for our purposes, and let's actually bring in our cube now. What's great is now you could just connect your primitives here. And so if we drop down an object merge, and we'll just pull up, let's move this out of the way. Let's make this bigger. And we pull up box 1, which is our most common colored box, and we connect this in here. We're going to get a bunch of boxes. As you guys can see, box 1. Now, something to keep in mind is if we were to try to render this right now, so as you can see there's a bunch of stuff scattered, we would actually have a problem, because Redshift would try to render this as pure real geometry. And the reason why they're white is because it does not know how to read. Oops. Let's plug that back in. For some reason, it just didn't, I don't know, it didn't want to refresh. And so they're green here. And we come in here. If we were to try to render this right now, and let's drop the coverage, which is kind of like the scatter count, and I don't know why it's doing that. It's weird. It's like, I don't know, some sort of bug, I guess, with Houdini. Sometimes Houdini won't refresh, so you just like click the tab and it'll reset the viewport. When you have something plugged into this slot here, this is your instance or input. So what it's doing is it's taking in your input geometry, scattering it on the points that you created with your mask and based on these parameters, and it's packing them as primitives. But the problem is, let's save because this might actually crash, because you're not, don't do this, but I'm just explaining it to you guys. If I were to render this right now, and actually let's get rid of our, or not get rid of, but let's hide our volumes because it's going to slow down the IPR. For now, we'll just hide that. If I try to render this right now, Redshift will render this as pure real geometry, but it'll also not render right now, and I'll explain why. So if you guys run into this, so if we hit render view, you'll get nothing, absolutely nothing. Well, there actually not nothing. There's a plane on the ground, but besides that, you'll get nothing. And if we were to turn on our terrain, we'll at least get our terrain, as you can see. Here we've got our terrain. And actually there's no point data on this, so let's actually the CD values for some reason it's not loading in. So let's pause the render and actually come in here and see what's going on. We should have, yep, CD, material, terrain. Yeah, it should be reading in the CD. That's kind of weird. Let's, oh, I know what it is. If we go to our object, I forgot to add the material. So let's let's go and add the terrain material. So if we render right now, we'll at least get our terrain. And that's it. But we're missing our scattered boxes. And so the reason why we're not seeing that is because Redshift gets confused and it cannot render height field data until you turn it into polygons, which is what we did here. That's what this is. And so it doesn't know to render the boxes or the terrain. And so in order to tell it to only render the boxes, you actually have to come into the settings here, and at the bottom of your height field scatter there's an option called keep incoming terrain. If you uncheck this, and let's just save, you'll notice that the terrain's missing. And if we activate it here, we have our terrain. This is our polygon terrain, and we have our scatter data. And so, but right now, if I render this, what we're going to actually get is real polygons. So if you were to render this with heavy meshes like trees and stuff, Redshift would just blow up. It'd be too many polygons. This might not even render, actually. I don't even know how many thousands of polys this is. Okay, here we go. So now we're getting our scatter on top of our terrain. But like I said, this is real geometry. These are not instances, and that's a problem. We actually want instances. So in order to tell Redshift that these are instances, we also, on this object node, have to go under the Redshift object properties, and underneath instancing, we have to make sure we activate instance SOP level packed primitives. This always has to be checked on if you're going to use packed primitives and instancing, like copy SOPs, all those nodes. Make sure to activate this. Otherwise, you're not actually instancing. Now that we have that activated, we're going to be instancing our geometry. And so it's going to be pretty much instantaneous, like as fast as it could possibly render. So cool. Now we've got our scatter going on. So for our next step, let's and we'll now start tweaking these adjustments here. And so if we come in here, and we don't actually need to see it in the render, it's faster to just use the viewport. The right now, all our boxes, if you can't notice, they're all crooked, and that's because they're following the surface normal of our terrain. And so you can adjust that, and there's all these parameters here. See, we have keep incoming terrain. Remember to uncheck this. Match normals with terrain. So if I uncheck this, you'll notice now, and again that bug happened, all the trees are straight, pointing up, which is what we want. And you can actually randomize the up a little bit, because we don't want them sideways, you know, off the sides of cliffs and stuff. So we're going to randomize the up direction. And as you can see, the more I do this, the more they lay down. We just want a little bit, not too much. So let's, I believe that's 20, this is based on degrees. So let's do 10. And the randomize yaw, this is basically the rotation. So if I go all the way, you'll notice if the boxes are rotating. So we're going to just go 180. Or whatever, you know, whatever you think works. So we'll probably just be sliding this around later. We'll just keep it at 50. Or, no, 100. Cool. Now, the instance on new points, this basically, if you disable this, you just get points. And it won't read in your object that you're merging in. So we want to actually use our boxes, so we'll keep that there. And the viewport, there's probably a way we could just fix this so it doesn't keep bugging out. If we just select this material and we just add it up here, it should just work, I think, without having to bug out so much. I guess not. Huh. Some sort of Houdini bug, I guess, I ran into. It's pretty weird. It, for some reason, doesn't want to display the material color unless I do that. I don't know. I might have to just restart Houdini and maybe it'll go away. But we'll just move on. But we will need to have our colors once we start adding more objects. And so right now, I think this is this actually, no, this might be enough. We could adjust the scaling. And so if I do 5, you'll notice that, let's zoom out, we'll have 0.5 to 5, and it'll be an even distribution. Like the probability of it being this big or this big is equal. And everything in between. You could adjust it using the exact scale, which does exactly what it sounds like it does. It gives you an exact scale. We're going to want a uniform distribution, and we want, I think, 0.5 and 1.5 is good. That means a few of them will be a little bigger, a few of them will be smaller. That might actually be too small, so let's do 1.5. Yeah, that might be a little better. And so they're a little bit smaller, but not that big of a difference, since in our reference they appear to be generally the same size. Maybe we'll do 1.25. Yeah, that's a little better. More variation. And so as you can see, they're randomly rotating. They're scattered around. And the way you could scatter, there's several options. Right now we're using our mask, our big tree scatter mask that we made earlier. You could also scatter like the old scatter, which is total point count. So if we use total point count, it forces across the whole thing, or not across the whole thing, but it doesn't give you just like a density. It tells you if you need a specific number of points. So right now we're at 1,000. If you need 10,000, and so on. This might be, this could be useful if you need a specific amount. Density. This basically is just the density. Do you want 0 to 1? If we go to 1, that's going to be 100%. This might actually take a little bit. And this parameter is based by meters. So yeah, this is just crazy dense. And so there's 9 boxes for every meter, which is one of these little world scale points. So eventually we're going to do something like this. We're going to get really dense. But these are the trees that aren't as common. They're around, but they're not everywhere. So we don't want it this dense. So we're going to actually just use by coverage for now. And I think we could go a little higher. Something like that. And there's one more option per point count, but I'll go over this once we start adding a hierarchy to what we're scattering, because this is the really cool new feature basically. Okay, cool. So let's check out our view. Okay, this is a good amount of variety, maybe a little too much. Let's just try 0.5. And yeah, I think that's fine. And we have all these options to relax the points so that they don't what's the word? They don't collide. So you don't have trees overlapping trees or different assets like rocks and stuff colliding. And this is based on the radius of the object. And so again, This is like the universal Houdini units. So this is a radius of 1. And if you remember, our box, it's a radius of 1, but then we transformed it to 3. So we scaled it up by 3. So if we were to zoom in on our box, this is 3 times bigger than that. As you can see, 3 of these wide or whatever, right? And so we need to keep this in mind when we actually make our tree. When we bring our trees in, we want to know the scale in world units, because that helps the scattering system learn how to lay it. Well, not learn, but it gives the scattering system information so it knows how to lay out our assets. So if we zoom out here and actually, there we go. Let's do this. And we come in here. And why is the material, it's really bugging me that it's white. I don't know why it does that. Yeah, maybe it's a Houdini bug. I don't know, in the build. Hopefully when I restart Houdini, this will be fixed. So yeah, what the outer radius is this tells you the absolute size of the object. So you see how we're getting collisions here? Our object is actually an outer radius of 3. So if we do that, notice how we're not getting collisions anymore. Because it knows to keep things 3 units away. And then our fall off basically controls how aggressive the fall off distance is. So if we move this to 0, things will get closer. Or not. So 0 is like nothing will collide. If we zoom in, you don't see any collisions anywhere. And the higher we go, the closer objects can get to each other. And so instead of an outer radius of 3, we'll just do 2.5. So that means things are a little closer, more clumped up, but they have space to breathe. So let's go back into our camera view. And let's now increase our coverage again. So let's try 8. Let's try 0.1. So now we've got our density back, but we're not getting self-collisions. And that's due to our radius and fall off. Let's try 2. That might be, well, 1.75. 1.5. Okay, that's good. Now, let's do that again. And actually, you know what? I'm going to save this and reopen Houdini, because once I start adding our other objects with different colors, I don't want to have to keep clicking this. So hopefully this bug will go away. So I'm going to save, and I'll be right back. Hey guys, so unfortunately, it seems like either this scene is bugged or Houdini, the build I have, has this weird bug. So if I actually, I found a workaround, but yeah, pretty much right now, the colors being, I don't know, it disappears if I try to edit or scatter. So if I keep editing it, yeah, it just, I don't know, it like resets for some weird reason. So in order to avoid this, the workaround for now, I guess, will be, we'll just use our color here, and because we have to keep these colors the same for Redshift to render because they're Redshift materials. And inside of our object, for viewport purposes, we're going to just use the color sop, and we'll just use the same colors. So that way, now no matter what we do, it works. And when we render in Redshift, it'll also work. So, okay, it's just a workaround for now. Hopefully, I don't know, maybe the Houdini guys will fix this in another nightly build, but just something to keep in mind. When we actually do render, we're going to just disable these. So for our next step is we want to actually scatter more of these yellowier looking trees, right? And so what we're going to do is we're going to just copy this, paste it, and let's move all this to the side. Let's actually do this. So we have more room. Let's move this down here. And we'll just call this tree green, tree yellow. And we'll duplicate this again one more time. And we'll call this red. And let's just adjust the colors to match. All right, cool. And so what's neat is using this system, now you don't have to actually, like we had before, we had to type out a string and assign a random attribute of zeros and ones in order to scatter everything correctly. We don't have to actually do that anymore. So if we right click this, you'll notice we have all these attributes, these point attributes. And what's neat is we're going to actually work with a certain attribute that it creates in order to randomize our point scatters. And we can control it like percentages, basically. And so in order to do that, we actually have to have to make attributes. And so right now, if I were to just make a merge, and we combine these two, and we plug them in, what happens is that you just automatically get 50-50. Which, you know, in certain situations, that might be perfect. That's all you need, right? But if you want to control this, and actually so you can see the attributes that are being edited, let's right click this and go into our spreadsheet. Let's open this up. And we look in here. Where is it at? Water variant. You'll notice in variant, this is basically our variations. It's right now it's at 0 and 1. 50% chance that basically it's going to select object 1 or object 2. And so this attribute's created for you and randomized for you. You don't even have to do anything anymore, which is awesome. But you can actually control the weights of the randomization using the weight attribute. And so, just so you guys can get an idea, let's actually let's build that attribute right now. So if we type in create and we get the attribute create, and we'll call this weight. This is the special attribute that you need. Where they mention this in documentation stuff, I don't know. I was watching the master class on instancing with the new height field system, and they briefly mentioned this for like 5 minutes or less, not even. So if you guys weren't paying attention, you might miss this. And so this lets you actually control the percentage of points based on percentages. So instead of using a point class, we actually want a primitive class, since that's what these are. They're primitives. And let's just load this up. You'll notice that now we overrode the automatic setup. And let's actually move this out of the way this way. Or actually no, because we're gonna duplicate this right now. And let's duplicate that, paste that, and let's unhook it. And if we adjust this value here, you could adjust it, think of it as percentages, 0 to 1, you could do it that way. So we're going to just say that this is 60%, 0.6. Right now you're not going to see any difference. And we're actually getting an error because we don't have the weight attribute on this yellow tree. So let's connect that now. And move this over. And we want 0.2. And boom. Just like that. You'll notice that 60% of our trees are green and 20% are yellow. So we could adjust this. Let's make this, I don't know, 50, 30. And actually, the what's left, it's not actually that percentage, because I was thinking of adding this. So once I add this in, it'll be 0 to 100% correctly, because obviously 5 and 3 is 8, so we still have 20% left over. So let's actually duplicate this again, and let's hook it back in. And we'll make this 0.2. And we'll plug that into the merge. And what do you know? Look at that. We have the brown trees, 20%. The yellow trees, 30%. And the green trees are half, 50%. So if we look at our reference here, I'd say most of them are actually the green tree. And so we'll probably end up doing 2 variations of the green tree itself also, and 2 variations of the red and the yellow. But for now, just for visualization purposes, so we can understand our scatter and how things are being scattered, we'll keep it this way. And let's actually increase this to 6. We'll keep this at 20. And this at 10%, which is only a few. Maybe we'll increase it a little bit, just to get a few more in there, maybe a little more. That's cool. And so if we look around, you'll notice how this system is working. It's really easy to do. It's awesome. You could now just plug in all your assets, make a weight attribute, control the percentages, merge them, and it'll scatter it all for you, and it automatically builds the variant attributes. So we have 0, 1, and 2, which is for each one of these. So as you guys can see, the possibilities are endless just this way. But that's not all. You can even get crazier, which is why the new hierarchy system, where you can scatter based on scatters, is just super powerful. So the way this works is similar to how trees work, where you'll have trees, which is what these will be, and then you have smaller plants that grow around them, like bushes and stuff like that. And so the hierarchy system with the scattering SOP lets you actually grow or scatter points around pre-existing points. That's what makes this so powerful. So let's actually save this and give a render a shot just to see what we've got so far. And for some reason it's not scattering with our different colors, which is odd. Oh, yeah, instance. We might have to actually disable these. Let's oops, no. Let's bypass these. And reload here. And yeah, that's weird. It's now giving us only one color, which does not make sense. Let's see. Delete. Let's make sure. Huh. That's strange. Give me a second to see what's going on here, because it should not be doing that. But let me look up what's going on here. I'm gonna pause for a second. All right, guys, took me a little while to figure this out. Funny thing is, it's a super basic mistake, but these things happen. So I don't know how, but my object merges, or maybe I just didn't do it earlier and I thought I did, which makes sense. My object merges were all pointed to the same box. So yeah, simple mistake. So this needs to be box 2. And this needs to be box 3. And so now we've got our colors. And obviously I'm going to activate these because the viewport just doesn't, that weird viewport bug. So that way we can get live viewport feedback. And now in Redshift, it should work, everything as planned. And the viewport, yeah, see, there we go. Great. Right now, our boxes are levitating off the ground for some reason. I think they're the pivot point is probably off, but yeah. So, but we'll deal with that once we start working with trees and stuff. What else? Yeah, because if we come in here and we just go to our box and our pivot point was a little lower, just say 3. Well, they went too far. Let's just say negative 0.5 and reload. Yeah, they're in the ground now. And the reason why it's doing that is because if we zoom in to our box and we check out our pivot point, it's way up here in the center. And so, but when we start scattering our trees and stuff, that our pivot position won't matter, since we'll just be able to change the pivot to the root, which is what you always want at the bottom. Hey guys, sorry, just paused it for a second. But yeah, like I was saying, we could just move it down a bit or whatever. So if we go down by 0.2. That should basically lower our points down far enough, yeah, into the ground. We could also additively create an attribute and just had the whole thing drop down a little bit, but the whole point is that we'll get this right at the object level anyways, since the trees are beneath the world space y-axis, so they go into the negative a little bit. So if we jump into the camera, hit play, and yeah, I mean, there's some of them are still a little above, but you guys get the idea. And I think actually if we match normals to the terrain, I think it'd stick closer, but I'm not entirely sure. Oh no, it's the same. So yeah, just keep that in mind. You don't want them levitating. So make sure your pivot points are low enough. And as you can see here, we've got the ignore pivot point attribute, if we had one. So if we uncheck this, let's actually see what happens. Nothing. So yeah, I wouldn't worry about it. Anyways, let's dive in here. And that's weird that these are black. Let's switch over. Yeah, it's definitely weird. Some sort of display bug or something. Again, OpenGL messing up, because these should be green. And we're getting some sort of error. Let's see. Shot material path and mismatch of attributes on the inputs was detected. Some attribute values may not be initialized. Blah 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 blah. Weird. Oh, that's why it's not flagged. That explains it. Yeah, there we go. Okay. So yeah, as you guys can see, we've got 3 different boxes, or what will be trees, scattered. We were able to control the percentages using the attribute weight, and we were able to combine them and scatter them and increase or decrease the densities, the rotation randomness, and the scale randomization, and control it based on a mask. So for our next step, we want to use the hierarchy system with the height field scatter in order to now, instead of scatter based on our mask, we're actually going to scatter based on the points that we already have created. And so in order to best visualize this, the color I'm going to use is going to be like a bright pink, just so you guys could see it in the viewport. And that's why I'm using these colors too, so you guys can get a better idea in the viewport how it's changing. Because if I was to use the actual trees, the colors are pretty similar. You wouldn't, it'd be hard to distinguish what's happening. And so what we want now for our next step is we want to actually scatter more based on not a mask, but the points that are already here created. And so that's what the hierarchy system is. So let's drop this down more. Let's just rename this to out, and let's save. And so let's bring in another object, or let's just copy this actually. Let's just copy this, paste it down here, and we're going to bring in box number 4. And for our color, we're going to just use super bright pink, just so you guys can see what's happening. And that might be too bright. Let's go a little darker. And so what we're going to do is, you can imagine this like bushes growing around these trees. And so if we drop down another height field scatter, HF scatter, what you'll get is the same parameters as before, but the difference this time is, instead of by coverage using a layer, a mask layer, or density, or total point count by mask, we're going to use per point, using source points as references. So if we plug this in here, nothing's going to happen. And the reason is because we're not pointing it to any source points. And that's what the source point tag is right here. So our source points are being generated by the height field scatter, which is this right here, the tag name, which is just referencing the name of the node, the operator SOP. And so if we just copy this name, or the name up here, and you could call this whatever you want. Let's just call this big trees. And we copy this name. We come into here, and our source point tag is now big trees. You'll notice that now we've got all these little points everywhere. Let's see. And all these points are growing based on our height field. The reason why they're on a flat ground right now is because I have to still connect our height field input. So the moment I do this, we're going to snap onto the height field. Oh, and also you have to make sure, actually this is our mask. You have to make sure that we keep incoming terrain is checked on, and you only disable that on the last height field before you render. So now if we look around, and you'll see that they're attached to the terrain around our trees. So let's come into this height field scatter. And now let's disable keep incoming terrain. And that'll get rid of our other terrain. And so if we look around now, oops, you'll see that we've got our terrain and it's using the mask data. You don't have to use the mask data. You could choose not to connect that. And it's growing around our trees that we are our points, as you can see. So what this lets you do, so if we zoom in here and let's scatter our smaller box, give this a second, we'll get that. And so what's great about this is it tries to not self-collide, and actually for our outer radius we'll do 1, and our fall off, let's bring it a little closer so they don't collide as much. Technically these will be bushes, so really it shouldn't matter too much actually, but if they collide, but something like that, 0.2. And we're going to disable the match normals with terrain. Actually, we don't have to. If these were going to be smaller, bushier ones, we want it to kind of hug the terrain a little more. And we'll randomize the yaw so it rotates. Let's do 100. And so we get random rotations. And now you'll notice that all the little gaps that we had before are filled in. But it still respects the mask we created on the slopes. See? You could also, like I said earlier, instead of reusing the mask, we can make a new mask. But I think this is fine. So if we look through, and let's save this out. Let's lower this. And let's actually make the box 4 material that pinkish color. So if we render this, let's just save, and we hit render, wait for our IPR to start. We've got all those little boxes filling in between our bigger boxes, which also have variation. So as you guys could see, you could keep stacking these. So you could add hierarchies that grow around things that are already, points that are already there, and you could also combine them with percentages like this. So if now we want to add our box number 5, and let's actually just let's just copy this weight attribute. Let's just delete that, plug it in. We're going to have a weight of, 60, I think will be fine. We'll copy this, we'll paste it, and this will be a weight of 40. Actually, let's do 3070. And this will be box 5. And for this color, we'll do blue. And we'll merge these together. Let's slide this back down more. Now we're getting the same growth pattern, but now we're getting what was it? 30% of these are going to be blue boxes now. And so let's actually come in here and make this material blue so it'll match in our redshift render. So if we render now, and let's save, we get the same thing, which is great. So let's pause that. Let's open this back up and let's activate all our VDBs just so we can see how the shadows roll on the surface. And I think this will give us a good idea of the density that we're looking for. And let's just do an actual render. And so for the next step now, that we're kind of satisfied with the layout and the percentages, and of course, you know, Houdini's Houdini, so we could always procedurally go back and adjust these points and the percentages. We're going to replace now the boxes with the actual tree assets that we want and adjust the scale and all that stuff accordingly to match. And so far, just from what I'm seeing, this looks pretty cool already, just from seeing how the shadow's hitting this mountaintop right here. And for reference, just so we know how many assets we're scattering, let's come in here. Let's middle mouse click this out while it's rendering. And so we have 164,000 packed geometry, which is, you know, that's a lot. It's 164,000 trees. And it's rendering, you know, pretty quick. No problem. And so we'll eventually swap that over to trees. Something that I was thinking about that I'm not exactly sure is supported is out of camera frustum culling of points. So if we wanted to delete the points that aren't in view, I'm sure there's a way. I'd have to look that up. And so I think I'll look that up before we move on to putting down our tree points, just so we can avoid having to compute all these points that are just not even in our view. And this already looks kind of cool. Just using these fruity, bright, rainbowy colors. The shadows give it a nice effect, a nice look. And eventually, the materials down here, I think I'll end up adjusting also. And yeah, this took 2 minutes and 30 seconds, and we've got, you know, thousands of scattered assets and a variety of them. And we've also got really complex volumetric lighting and atmosphere and volumes. So yeah, so I think for our next step, we're gonna start bringing in our trees and replacing each box with our trees. And I'm gonna see if I could find a way to cull the points that are not in view, but I actually haven't looked into that to see if I can maybe find a way to combine that with our height field scatter. But so yeah, I'm gonna pause this and start looking around my collection of trees and pick out the ones that I want to fill these in with. So yeah, I'll be back. Thanks, guys. Hey guys, so after spending a little while making some custom trees that I'll end up sharing with you guys for free, since I ended up building them myself, based on the reference, and I looked up the species of trees in the area and tried to generate them similarly. And basically what we ended up doing is, instead of using the boxes we had earlier, I've merged in our trees. And so now we've got our trees in here, a couple different varieties. And I made a test render just to check out kind of what's going on here. And so our results are pretty cool. We've got good amount of variation and stuff, and different types of trees. I adjusted a little bit the scatter percentages so we'd get more of the green and less of the brown and yellows, and basically using the techniques that we learned earlier. And something that I want to do actually is I kind of want to make the some of the trees a little bit smaller and less common. Right now I think the foreground's a little too crowded, and I'll probably end up adding a little bit of displacement and stuff. I also noticed that our trees are actually off the ground. You can't really notice it too much, but they're actually floating. And so I'll explain to you why that's happening. I ran into this earlier with the boxes, if you guys remember. And so probably just end up breaking this up and stuff. But yeah, as you guys can see, the results are pretty cool. And you know, we've got a lot of stuff going on. We got the volumes, casting shadows, we got atmospheric haze from a VDB, we got tons of scattered trees, and like I mentioned that I was going to look up how to cull the instances beyond our camera angle, so that way we don't have all these extra points. And so I did a little bit of digging around and asking around some Houdini groups, and I was told of a method of doing it, and so I ended up building a custom Houdini digital asset that I'll give you guys so you guys can do this also. And you can use this to basically delete points that are beyond your camera view, and I'll actually go over that right now and also explain why some of the points here are floating off of our surface. And it actually has to do with the way Redshift interprets packed primitives. And so I actually had to ask the Houdini dev about this because I didn't know what was causing this. But after he explained to me the pivot point system, how it works with packed primitives in Redshift, it actually made sense. So I'll explain that right now. If basically, and I'll also explain how to use proxies at the end, because this requires, to use proxies in this system, it takes a little more work. And I know a lot of people don't like using wranglers and stuff like that and writing in Vex, so I'll leave this for the end. But as you can see, just using packed primitives, you can instance a lot of stuff. So where were we? Yeah, to come in here, the reason why things were lifting off the ground is actually, if we come down here, and we have to unlock our height field scatters, and we have to go inside them. So if we just go inside them right now, you'll notice that the nodes are all locked. So we have to right click this, and we have to select allow editing of contents. So that unlocks the node. We need to do that for this one also. And let's just save, or actually let's save a new version. So this will be version 3, and what I made it's this node called, I called it the camera frustum point cull. And so what this does is this HDA, if you come in here, it just has an input. It's an attribute wrangle that basically deletes points based on the volume SOP, which uses your camera. And then it outputs this, and I just connected everything and gave it custom parameters that you guys can manipulate. And so what you do, let's actually delete this, but so you can see what happens if I move the camera around. Let's just move our camera somewhere down here, right? And if we dive in here and we come down to our output, oops, we actually need that connected. What we can do is we drop down my custom HDA. You could actually just do this yourself if you don't, but I think it's easier to just build an HDA. And like I said, I'll give this to you guys so you guys can use it. And basically you drop this in here, and now we need to select our camera that we're looking through. And for our distance and our near distance, this basically controls the points that we're going to delete, how far and close to the camera they are. So we're going to just make a big number here because I think it's like 4,000 meters the distance or something like that, I'm not sure. And our overscan, this lets you kind of blur where the points get deleted from, so you don't have to delete the points that are really close to the camera. You can kind of delete them outside of the view. So if, let's just pin this control panel so you guys could see. If we jump back up and give this a second to cook, you'll notice that all the points got deleted except for the points in view of our camera. And so this is pretty neat. It lets you control where the points are. Let's just keep this 1,000. I think we'll fit here. Oh no. Well, let me see. Zoom in here. Yeah, no, that's fine. 1,000's enough. And we'll have a little bit of overscan. So let's just add a little extra. Let's just do 2 here. That might be too much, but you guys could see how it extended the distance. So let's do 1.1. Maybe 1.2. And 1.2 on this side. And I think 0 is fine here. And so this controls the X and Y. Or actually, let's see. Let's drop it down a little bit. Let's do -0.9. So we get, that's maybe too much. I meant, what is it? 0.1. Let's do that. So that gives us a little extra on this side. And we'll do another -0.1. And so this is the y-axis up and down, which is, I think it already fits, so we're not seeing a difference. But the X and Y, if we look through the camera, it's giving us a little extra edge right here and right here. Maybe we can make this side a little smaller. Let's make this 1.1. It did get rid of some of the points down here. So actually, let's keep this 0.2, 1.2, and we'll make this also a 0.2. And that'll give us a little extra space over here. And cool. So what that lets us do now, and let's make this 0. This gives us a lot less points because we deleted all the extra points that are beyond our view. So if we look at this now, we've only got 6,675 packed primitives instead of processing the 100,000 or whatever points we had. And that'll just save us processing time. And so we'll just copy this and we'll dive into here and do the same thing. We'll just paste this down here. And connect the two. And jump back out. And that way, our final output is only 65,000 packed geo. So it'll save us a good amount. And for our scale, I actually want to, let's unpin this. I want the smaller bush trees to actually be smaller. They're too big right now. So I'm going to try, let's try something like 0.5 and 2. So 0.05, 0.02, and as you can see, it kind of broke up our surface. Let's look around. And our computer's actually starting to slow down because we're displaying some of the actual geometry. So in this situation, hit D. Let's go to the display, and for point instancing, we could just turn it off completely, and we could just use the IPR, or we could use location. A bounding box for, I think we'll use 50%. And hopefully that'll help kind of get rid of some of our viewport delays. Well, no, it's still pretty slow. So actually, what we'll end up doing is we'll change the display of these from full geometry to bounding box. And let's just select them all and change that to bounding box. And it's not working. Let's do bounding box. Well, no, that'll do a whole bounding box for everything. In this case, we might actually have to jump into our packed prim settings. So if we dive in here and we look for our copy to points, instead of full geometry, we'll just use bounding box. And that should give us bounding boxes. Let's see. Let's come up here. And let's jump back up. Yeah, so now we've only got boxes. So that that made everything a little more manageable. So if we come in here and we check everything out, we've got our assets scattered around, but I've noticed that our smaller trees are down here. And let's see why that is. Match normals with terrain. Yep, keep incoming terrain. That is strange that it's doing that. Let's see. Match normals of terrain. Huh. It's pretty strange. We don't want to be matching the normals with the terrain, actually. I don't know what's going on here. From connectivity, it's because we're calling the points up here. might be the case. Let's bypass. Give that a second. Yeah, that's what was happening. So pretty much due to deleting the points at the first step, when you have a hierarchy, you actually don't want to use a point culling method. You want to use that as your last, whatever your last scatter sop is. So you'll drop it in there instead of earlier. And let's actually get rid of match normals with the terrain. Or no. We might actually keep this, since these are supposed to be smaller bush-like pieces. They could match the curvature. And so now we've got some bigger gaps. I think we might have too many gaps, so maybe we'll increase the scale. Let's bring this back up to, let's try 0.1 and 0.2. Maybe we'll do 0.3. Yeah, let's try 0.3. And so this will give us a little more breakup in between, which makes the things a little more interesting. Because if there's too many trees clumped together, we don't want it like that only. And like I was saying earlier, one of the problems is that our trees are floating, right? So if we look at this, we've got them floating off the surface. And if you look around, it's like a lot of them are actually floating off the surface. If we come in here, some of them aren't, some of them are. And so the reason is, if we jump into these, because of the way Redshift works with the packed primitives, you actually don't want centroid, the pivot location. You want the origin. And centroid basically puts the pivot in the center of the object. So we want the origin of our pivot. And we want to do that to all our scatter sops. So we'll come in here, change centroid to origin, and jump back up. And so by doing that, these should, well, this one's coming off the terrain, but the surfaces should be closer or underneath. As you can see, if we look around underneath it, a lot of stuff is now under the terrain. And so if we, well, actually, let's just, so I can show you guys the difference. Let's pin this and let's jump in here and let's turn that off. Or actually, no. In the viewport, it won't make a difference. That's right. The viewport will look right, but Redshift won't. And so let's let's start the IPR so you guys can see what I mean. Let's see here. And let's go back to our camera. And if we just start the IPR in this little area right here, give that a second to start up. And these tree assets are pretty complicated. They're like 1 million poly each. So just so you guys know, they're not super detailed, but they're pretty detailed, and you guys will end up getting to keep them, which is cool. And it might take a second to build this scene because we're not using proxies. So I might actually pause. Uh-oh. Looks like Houdini did not like that. So now I have to pause it, guys. I'll be back. looks like we crashed. All right, guys, back. So yeah, we crashed, but had to rebuild everything again. Had to add the point culling and stuff like that. Yeah, and I had to readjust the density and the scale. So right now we've got the a lot more of these smaller boxes. I ended up using the exact number for our scatter to instead of the Poisson distribution, which kind of more naturally grows it. I couldn't get the Poisson to be dense enough, so I just went with exact number and said 50 points per other tree. So we're at 174,000 packed prims, which is a good amount just in this little area here. And so it kind of filled in the gaps a bit, but it also gave us that variation in height so that we've got the smaller little bushes with the bigger, larger trees. And so let's actually give this a try just so we could see what we've got. So I'm going to save this, actually. Good idea. And I'm going to fire off a little render, and I'll show you the difference of what happens when you enable or change origin from centroid to origin, just so you guys can see what I'm talking about. And you only have to do this when you're using packed prims and the height field scatter SOP. It's just the way Redshift interprets packed primitives pivot point for instancing. So I'm going to just fire off a render, and I'll pause this for a second so I don't bore you with 2 minutes of rendering. So I'll be back. Alright guys, I'm back. So to show you guys the example of what I mean, so this is the finished render, the correct one, and I actually like the gaps and layout a lot better now that I adjusted the scaling and stuff. So we've got more the big trees with the little smaller bushes and stuff in between. And I just need to probably add some noise on the terrain, but even then I think from a distance it reads pretty well. But like I was saying, if you look at the trees here, they're touching, they're connected, right? And this is what happens when you do not have this change to origin. So by default, the height field scatter uses centroid, and Redshift, it'll look good, it'll look normal in your viewport, like there's no problem, right? But Redshift itself does not respect the centroid pivot point, so you must change this to origin. And so when you do that, you won't get stuff floating in the air. It'll actually snap down to your terrain surface like this, which is what you want. So again, just want everybody to remember to go inside the height field scatter and change it from centroid to origin. This is pretty important. Otherwise, you're going to be wondering why your scattered objects are floating in the air and stuff, and not know what's causing the problem. Cool. So let's move on. I think for our next and final step, we're gonna let's hide this for now, and we're gonna export these as proxies, and basically I'll show you how to do that, like how to use the height field system, and it's a little more complicated. Like I said, for most people, packed primitives with Redshift support, and just connecting everything like this, that's that's going to work fine. I mean, look how heavy this is, and it's rendering, no problem. So, but if you need to use proxies, it's going to get a little more complicated. And so I'm going to go over some of that process right now. Where was I? Let me make sure everything is in center space. Yep. Just want to make sure everything's in the right locations and stuff. Okay. So, as you guys may know or may not know, you've got the Redshift proxy SOP. So if you type proxy, you'll get the Redshift proxy output. And we could just connect this into here. And you'll have your name and whatever you guys want to call it. You can check off or on different options. We're gonna render this out, and you just hit render to disk. And so while it does that, I'll actually go open the folder so you guys can see where it's going. So you can see it's going $hip, which is our scene project, and it's going into a proxies folder. So if we go to our scene and we go into the proxies folder, we've got our proxies in here. And so we just wrote out Coast, Live Oak, Spring, right? This one right here, 27 megs. And so I'm gonna just go ahead and rewrite these out. I don't think I changed anything, but just in case. So render to disk. We'll render this to disk again. And we'll just do this for all 5 of our files, our plants. And you could do this, obviously we could add more plants and stuff, but we're going to just do 5 for now. And it's easy to make more plants in SpeedTree. I think I actually said I would eventually make a only SpeedTree tutorial. I know there's not a lot of information out there about it, so I think next month I'll actually do that, or maybe we could cover the volume, the cloud shading, one or the other. But SpeedTree definitely needs to. I need to do a tutorial on that and explain how you can edit stuff to have seasonal changes and just to get a lot of variations out. It's really powerful and really easy to use kind of once you figure it out. If you're used to Houdini and nodes and stuff, it'll make sense. Cool. So we now wrote out all our proxies. They're all here ready to go. And there's 2 ways we can do this. You could either load them in this way, where they're in our scene, and let's just hide them. Or you could use instance file, where you don't have to load them into your scene here as objects, and you just tell Houdini where they are in your system. And so this is technically a little lighter, rather than having to load them here and then reload them. So I'll show you how to do both methods. It's pretty much the same way, except instead of using the instance attribute, we're going to use instance file, and the direction we point it at will be different. So instead of pointing at our object context, we're going to be pointing at a location on our hard drive. And so yeah, let's do that right now. So let's actually save. And so if we jump in here into our scatter, and let's actually activate that again. So it might take a little second to compute our attributes. And we jump in here. basically, by using the object merge, we're merging in our actual files, these ones, right? And so these live, they're BGOs, but they live inside of our Houdini scene. And so our packed primitives are referencing these objects. And so to work with proxies, you can't just, instead of using our object, you can't just say, oh, I want to use, our proxy version right there. You can't just change that and it's going to work. And the reason is because of the way that Redshift works by interpreting the packed primitives. It just won't work. It cannot work this way. And so what will end up happening is you'll just render boxes, empty boxes, with no shaders, no tree, nothing. And that's one of the unfortunate problems with the packed primitive method. You can't instance proxies. You can instance objects, but not proxies. And so in order to work with proxies, and let's just hit that, you have to do a couple things. You have to actually create the attribute, and unfortunately it's a little complicated. That's why I'm saying this is a little more advanced. Most people might not have to do this. You could just use this method and merge objects in. So the more advanced method would be, we would actually detach these. So we would cut that. And we're going to get an error, obviously, because there's no object now. And if we actually check out the spreadsheet for this, as you can see, we're getting all these errors and stuff, and it doesn't know what to do. It's telling us, invalid color, blah 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 blah. So we're gonna just delete or disconnect these since we're not using them. And it's going to say, well, we have no source. And so what we need to do is we need to create a temporary object that Redshift can't render, that's invisible. So we're going to just say line, and we're going to just connect that, and we're going to make 3 of these. And the reason why we have to do this is so we have something for our attributes to be created, so that Houdini can use all these attributes and scatter all these points and do what it's going to do. And the reason being is because we need all this data. We need variant and all this stuff, right? Because this is what's going to end up controlling our proxies. But if we don't have anything connected, none of this data gets built. So what we're using is a line, which takes up no space. It won't get processed by Redshift. So it's just temporary. And we're going to do the same thing down here. So if we move this down, and actually let's move this up, and let's disconnect these. And we'll just connect these for now. And we do the same thing. We just duplicate this. Let's move these. Let's move this to the side. And we move these down here. And we connect them. Give it a second to process. So we've got all these lines, but they won't render. They don't compute as anything. So for us, it won't matter. And I'm gonna keep this saved. And I'm going to just show you an example of what happens if we render right now. Just so you guys can see. We hit render. And actually, I probably shouldn't have done render because it's going to process the clouds, and that might take a little while. So, but we'll see. What ends up happening is Redshift can't render these lines, but what happens is the data, the attributes, are all here. So you can see we have our height, our normal, our orientation, our position, our p-scale, etc., etc. Our variant, which is important. This is our randomization. So you can see we have our terrain and it's empty. There's no lines or anything, even though our viewport shows the lines. Redshift can't render them. And so, but like I said, this is just a placeholder so that our attributes that we made earlier using weight and all these attributes that we controlled here will work. And so the idea is that once you're happy with the layout and you want to use proxies, you need to do this. So you need to connect everything to lines, right? And the final step is we need to create the attribute to tell it to read the proxy files. So if we start typing Wrangler, and I'm sure there's a way we can make this process into an HDA that we could just connect stuff to, but I'm gonna have to research that. And I could try to make one similar to what I did with our camera frustum point call. I just made it with nodes and turned it into an HDA. I'll see if I can make this, the code we're going to type in, something we can plug in, but it's going to be a little difficult. And so we've got this attribute wrangle, and we're going to plug this in at the bottom. And we want this to run over points because that's what we're processing, a bunch of points, point data. So if you middle mouse click it, you can see that we're still getting our attribute data, our point data. But this time we have to start typing some vex, which, you know, I know everybody hates about Houdini because vex is, you know, complicated and stuff. And so what we need is we need to instance our proxies, these proxies that we created. We need to instance them using the variant data, which is 0 to 2. So 0, 1, and 2. And that's what tells it where the points go, right? And so in order to scatter stuff around. And so to do this, if we middle mouse click this, you'll notice that we've got, here's our variance, and here's our variance again. And so if we middle mouse click this, we've got variant 0, 1, and 2. And if we click this, it's the same thing, right? And so we have to write an attribute wrangle that reads in this variant data and then uses the instance file attribute to pull these up. And so for step 1, and like I said, this is a little more complex. You know, if you guys don't want to bother to do this, using packed primitives the regular way is totally fine. And so we need to make like an argument saying if and then parentheses integer, which is what the variant is, because it's full numbers. It's 0, 1, 2, 3, not 1.1 whatever, 2.2. No, that's a float. We're using integers, which is 1, 2, 3, 4, 0, those full numbers. And so then we type in at, which is short for attribute, variant, which is the name of the attribute we want, and then equals, two equal signs, 0, close parentheses. So what this is saying is, if variant is 0, all these, then what you're telling it is, then you're going to say it's going to perform a string, which is what S is. S is string, instance file. We're going to do the instance file method first instead of regular instances. So it's going to pull up one of these from our hard drive. Instance file equals and set. So this is the string we're gonna set it to, and quote parentheses again, and then quotes $, hip, and this is because this is where our project folder is, $hip, and then we're gonna type in the name of the proxy we want. So for zeros, we want it to, I don't know, let's just say we want this one right here. So we can just copy paste the whole name. Actually no, let's do Live Oak Spring. Let's just see what happens. And we type, and actually we need our folder structure. So it's inside a folder named proxies, so we got to make sure we type that in, / proxies. And so this is the inside our project, inside of our proxies folder, look for Coast Live Oak Spring .redshift, which is a proxy file, and then close the quotes, close the parentheses, use a semicolon to end our command, and then use another bracket. So basically what we're saying here is, if integer variant, which is our attribute, if variant is equal to 0, instance this file. And so what will happen is, let's just save this. If we hit IPR and give it a second, it should instance, it should, but it's not for some reason, weird. Might be because I have packed prim selected. Let me disable that and reload. Give that a second. I think I have to disable this since we're using proxies now, not the packed primitives. But let's see what happens. It might not work. It should work, but we run into problems. And so that's why we're here to figure it out together. So I'll give this a second. And actually, I paused it real quick, and I was reading this over again, and I realized that I mistyped something. If you look at hip, it's the number sign. This needs to be a $sign. So I accidentally typed that in wrong. So $sign hip should work. And let's just give Houdini a moment so it doesn't crash. Why is it not deleting? There we go. $sign. And now this should work. So let's save this. Small little typo like that can cause problems. So yeah, $sign hip, not number sign, accident. So let me pause this again and see if it starts rendering. Okay, and yeah, that fixed it. So right now we're only scattering one tree, which is that one that we chose. But as you can see, this is loading directly from our hard drive where our scene proxy, our scene setup is. And so what this is, like I said earlier, this string is basically saying if integer attribute variant is a 0 value on one of the points, instance this file from our hard drive, and that's it. That's all it's doing. And so you could just copy paste this and change the variant for variant 1, 2, 3, 4, etc., and change the asset that is actually being instanced. Let's see. So hopefully that makes sense to you guys. This is, like I said, this is a little more advanced. This is a little more complicated, but it does work. Where was I? Yeah, that should hopefully that explains things a little bit. Hey guys, sorry, had a crash. But yeah, we left off here on proxies, right? And so this is just going to let us instance this file everywhere, right? But what if we want to instance multiple proxies? So there's a problem here. And the problem is, we open up our spreadsheet, or just go to here. The problem is that if we come down to here, our variant is only 0 to 2, but we have 5 proxies, 5 objects. So why do we not have 0 to 5? And yeah, that's part of the problem. And so the problem is it's due to the tag. If you look at the tag field here, this is big trees. And so 0 to 2 is 3 objects for big trees. But then if we come up, let's scroll up quite a bit, we start getting height field. And that's the reason why this is called height field. It's just because that's the name of this. If we change the name here to bushes, for example, our tag will be bushes. And we're going to have to let that process a little bit. But see, here we go. Now we've got everything tagged as bushes. And so it's 2 attributes together. It's the variant and the tag. So the variance is within bushes tag of 0 to 1, which is our 2 our two proxies. Meanwhile, if we come down, once we get the big tree, here we go. Scroll down right there. And now once we start big trees, we have 0 to 2, which is 0, 1, 2. And so what we need to do is we need to extract the variance not for everything as a whole, but to separate them so that big trees have its own 0 to 1 variant and bushes have their own, or big trees have 0 to 2 and bushes have 0 to 1 as their own attribute. And so in order to do that, we actually have to do that step before they get merged down here. So we need to do that up here first, split this as its own attribute, and then pull it back in. And so I'm sure there's probably a way in Vex to do this where you tell it check first the tag attribute, and then if this is true, then check this also. You know, I'm sure there's a way to do it. Like I said, I'm not the greatest at Vex. I just know some basic stuff. So, but I'm sure there's ways to do it. But I thought of a way to do it with SOPs. I'll have to look into how to do it actually using Vex, because I'm sure it'd be easier to just type in something here and then, you know, get to it. Hey guys, so I ended up pausing the video right now just to look up how we could actually do this and use, because I was gonna do a SOP method to split up the bush and the bushes and the big trees attribute, but I decided that there's actually a way to do this in Vex and save us time having to do all that. Before I actually show you guys that, right now we just have one. We're using variant 0 to instance the one asset. So we want to scatter all of them, and we need both variant 0 attribute and also our tag attribute. So right now our attribute spreadsheet is pretty busy, and we don't need most of this stuff anymore. So what I'm going to end up actually doing before we get to the attribute wrangle is I'm going to just delete some attributes. So let's just come down here and drop down an attribute delete. And we're just going to go ahead and get rid of any extras. So right now we do need the normal, we need the position, we don't need the texture, we don't need bedrock, debris, all the height field stuff that we made earlier. We don't need any of that, so let's get rid of that. Height, mask. We need orient, we need p-scale. Let's get rid of sediment, slope. We need the tag, the variant, and we'll get rid of water. And so that narrowed our options down quite a bit. And actually, I don't think we do, I believe, need the big tree scatter, but I'm not. Let's just keep it. Right now, it's clean enough. So, cool. Let's get back into our wrangle here. And so if you look in here, we've got our tag, bushes, and then we've also got our big trees tag. And so the problem that we've got is that our variant goes 0 to 2, but it also goes to 0 to 1 for bushes and for our trees. And so we have to first have a logical statement saying if tag big trees is true and number 1 or 0 or 2 is true, then do this. Right now we only have if variant 0 is true, then instance file proxy whatever, right? So what we need is we need to tell it two things. So we need, not only do we need it to check variant for number 0, we need it to check the tag for big trees. And so we're going to start off with, this is our shrub, so we actually want bushes first, summer, which is our 0 number variant. So what we're going to do here is we're going to add to this vex expression. So we're going to add also the, and let's space this over. We're going to add string, again, because tag is a string, it's letters, attribute, and we're going to call this bushes, which is the name of this, which is, if we come up here, oops. Oh, and we're getting an error actually, so if we come up here, we'll see it. And so if we look under tag, we have bushes as a tag, as a string. So what we need to do is come back here, and so we want to add string, attribute, bushes, and then, well, actually not attribute bushes, attribute tag, and then if the tag says bushes, then also, and this is what and in the middle here is going to do, and means also, and. So it means, so what this is saying is, if the string tag bushes is true and integer variant is 0 also, then do this. And so boom, now we've got, now it works. And so what's going to happen is, if we check our instance file attribute right here, you'll notice that it's going to get our chamois shrub summer, and it's going to instance it. And all these are empty because it, the two properties aren't lining up. So if we come down here, you'll notice that these are still bushes, but variant is now 1, and so they're empty. And so this is what's going to help us scatter now our bushes. So now all we have to do, we could just, and so if you guys can't see that, let me just copy paste this, and I'll open it in Notepad. And so here we go. So what this is doing, what this is saying is, if our string tag, which is up here, says bushes, and our integer attribute variant is 0, then what so it checks these, and if these two are true together, then we're gonna use the string instance file, and the file we're gonna instance is set to our proxy, which is our hip proxies folder and the name of the proxy, right? So what we need to do is we just need to make one of these for each of our proxies we're scattering. So we'll just copy paste. We know we have 5 files, so we'll do that. And 2 of these are bushes, so we're going to change this variant to 1, 1, 2. This is going to say, instead of bushes, it's going to be, I think, big trees. But let me make sure. Let's go down to the bottom. Yeah, big trees. So we'll just copy that, paste, paste. And our variant, we want 0, 1, 2. And so the rest is fine. And all we have to do now is change the name of our proxies. And so one of these was fall. Oops. This one was spring, which is our most common one. Actually, this one was fine. Summer and fall. So now if we copy this and we paste this in, we've got 5 instance file proxies that are going to read from our folder. So if we come in here and we go inside of here and we go into our proxies folder, we've got our 5 files right here. And it's going to check for these attributes for both our tag bushes and for variant. Or not bushes, but our tag attribute and our variant attribute. And so with those two together, what we end up with is it instances. As you can see, if we check our instances now, you'll notice, oops, let's move this way. Our instance file now is instancing our shrub, our summer shrub, and then we've got our spring. Or actually, oops, I made a mistake. This is these are supposed to be our tree name. So our tree is called Coast Live Oak. So let's copy that and let's fix that. So let's copy paste Coast Live Oak Fall. Oh no, not that one. The this one. Coast Live Oak Spring, Coast Live Oak Summer, Coast Live Oak Fall, and let's just highlight everything. And let's come back in here. Let's delete this, paste it in, and here we go. So now it updated. So now we've got our spring trees, and if we go further down, we have fall, summer, and so on. And it's instancing the proxies onto all our points the same way as we had them with the packed primitives. It's the same thing, except instead of using packed primitives, we're instancing actual proxies. So right now, how we had it earlier, we only had one proxy, so only one tree was scattering. So let's save this and we'll render this out real quick, and I'll just pause this while it renders. Or actually, I should probably just do an IPR. Well, I'll let it render, and I'll pause it for a minute, and I'll show you the result so you can see the difference now that all our trees are scattered. So I'll be right back. All right, guys, and here's the result. Took a couple minutes. Pretty heavy of a scene, as you can see. Lots of volumes, really dense volumetrics, atmosphere, thousands and thousands of trees. Each tree is like 1,000,000 poly plus. So yeah, and as if you zoom in here, you can see that we have different variations of trees, different sizes, and overall just, you know, nice little image. And so hopefully after watching this, guys, you now know how to use this new height field scatter system with hierarchies. You know how to use just packed primitives, which I think most people, for most circumstances, that'll just work better for you guys. And at the same time, we also looked into how to build, or not how to build, but how to use my custom camera frustum call. And so you guys can delete points. I'll be giving this to you guys with the files, and you guys can dive in there and check it out yourselves and see how I built it. Also, we looked at how to scatter proxies on here and how to use an attribute wrangle to scatter a little more complicated proxies. Of course, we don't have to do it this way. This method is if we wanted to scatter proxies and at the same time they all have different names, like so we have, you know, summer, fall, etc., etc. One of the methods we could have used is the old system that we had before that I've showed in the other tutorials. So if we were to just call this obj1, let's just copy paste this, obj2, obj3, obj4, obj5, right? And we just dove in here, or actually not dove in, and we have our proxies right here, right? Using this method, actually our bushes should be their own, so then we could just do this, like tree 1, tree 2, tree 3, and bush 1. And actually it should be 0. Well, it doesn't have to be 0. We do it this way. Bush 2, right? And let's say we wanted to, instead of using an attribute wrangle, we wanted to distribute them the same way. We can come in here, and instead of using this method, we could create a rand, or actually let's create a attribute first. So this would be like an easy way to do it with SOPs. Well, not an easy way, but it does the same thing. It'll do what we did here, typed, which is probably faster because we just copy pasted and just changed the numbers, while this method will do a similar thing, except it'll be only SOP. So actually, let's just do that right now. Let's go ahead and try to do this. So after the attribute delete, what we could do is, let's actually get rid of that. Let's type in attribute, and what we want is an attribute, I think, rename. There we go. And so what we would end up doing is we'd pull in this attribute, and actually not from here. Well, yeah, no, that should work. Hold on a second. Let me see. No. What we would need to do is we'd actually need it up here. Up at Highfield, Mass Clear, big trees. So we would need to copy it here. And let's move this way. And we would need to copy what we're getting from here is our variance. So it's 0 to 2. So what we want is we could just get rid of all these. We just want 1. And what? Oh no, wrong attribute rename. Yep, from. Okay, so what we want is variant, and we'll just call this tree rand. And so that'll create a new random number system right here that we've got, called tree rand. And what we want to do, we'll move this down, is we want to actually, let's move this to the side. So this will be its own distinct path. And we're going to merge it back in here. And what we're going to do is actually rename also. So let's rename. Plug this in. We're going to rename our variants again, but this time from let's see here. This is giving us all our variants. So what we need is our variant before that gets merged in. So let's try that. And let's see here. No, this is giving us big trees also. So let's see. Well, let's see what happens. If we merge this in, we should have we've got variant, yeah. And so as you can see, variant is -1 on all our bushes. And actually, it's bringing in the attribute. Oh no, big trees is -1. Bushes is 0, 1, and 2. So it's bringing it in twice. So actually, what we need to do is here, we need to delete attributes. So, because it's trying to bring it in again twice. So we're going to, at this stage, we're going to get rid of everything else that we don't need. So position, texture, bedrock, debris. We don't need any of this stuff because height, mask, orient, p-scale. This is all this data is already coming in on this side, so we don't need it again. Double. P-scale, where were we? Sediment, slope, keep tag, and variant. And if I look here, we should have, yeah, we've got variant 0. I could probably get rid of the tag also. See what happens. And variant 0 to 1 and 2. Yep, okay. And we could probably get rid of big tree scatter. And that's just, so what we ended up with is just our pure variant. And we're converting that to tree rand at this point. So now we don't have variant anymore. And so when we come back down here, what we're going to end up with is, and we're getting some sort of error, mismatch of attributes, big tree scatter tag, p-scale. Why are we getting this error? Let's see here. Should it, well, even though it's mismatched, it should be fine. But just to make sure, right here we're at no tag. Bushes is -1. Big trees. And these points should be erased actually. So let's position, yep, slope variant water. Should be okay, but let's see. I mean, it's a little dirty, but we're gonna test this out, see what happens. And if we merge this back in here and we check out our points, yeah, should be okay. So what's happening now is tree rand is 0, and we're getting bushes -1, -1, -1, -1, -1. No, I think we do need to keep the tag. So let's keep that in there. Okay, let's see what happens. Okay, so now we've got big trees, but it's doubling up. So maybe we could get rid of it on this side. Let's see if we could. Oh no, we need tag also. Let's just see what happens. Shouldn't matter too much. Let's see. Because what we need is to split bushes 0 to 1. Yep. We need to split this out also. But if we do that, we're going to end up with all these numbers out here too. See, that's the problem with this, is that it's not giving us unique variants. It's giving us unique variants based on a tag, and so this just causes problems. Now that I think about it, I don't know if it'd be easy to do this by splitting it up and merging the attributes back together. Because what we're getting here is big tree, bushes, and big trees again. That's -1. And then these are 0 to 1. And now these are 0 to 2. No, I guess this should work. It's a little, yeah, believe it'll work. It'll be sloppy, but it might work. Let's see what happens. So let's build a attribute. No, a random. And actually, no. We'd have to do this 2 ways. So we'd have to now build an instance SOP. We'd make 2 of these. Delete this. Object merge. We'd pick our out that we had earlier. where is it at? Terrain, out, copy this, delete this, drop this in here, and we'd actually be able to hide this, come in here, and what we're going to do is instance our files based on the parameters that we pulled in. And so we're going to instance our files on tree rand. So we'll call this trees instancer, bush instancer, and we'll create a rand attribute. And actually we'll make a regular attribute first. And so what this is going to be is our selector that selects these, the 1 through 3 on our tree. So what we need is, we'll just say tree S for tree selector, and it's going to be over points, and we want integers, and then our randomizer, we're going to type in tree S, which is our tree selector. And so if we look around, we'll have that attribute somewhere around here. Yeah, right here. So we got tree S, and it's going 0 to 1. And we actually need, 1 to 3. So we'll say 1, 3, and that's it. And using that, we'll now type in our new attribute, and this is going to be our instance file attribute. So if we come here, type in instance file, and we switch to a string, and let's see here. And actually right now, if we do this, it's pulling in all the points, I believe. Yeah, it's going to grab every point on here. So what we need to do, maybe we could group. If we group points, and we use the attribute, let me see if this will work. And our base group is based on our string attribute. Oops. Big trees, maybe? Yeah, let's see what happens. I don't think this will work, actually. Bad pattern, possible pattern in the router range or syntax. No. No, this isn't going to work. Huh. Let me think for a second here. And actually, unfortunately, this is probably going to require a little bit of Vex again. So, the way you'd have to do this is you'd have to use a group expression. And we're going to just drop that down here. And we would basically be grouping together everything that says big trees into its own group. And so to do that, we're going to have to use a string attribute tag, which is what this is, and equals quotations, big trees. And I believe that should work. Or actually, we need it on not on primitives, but on points. And yeah, there we go. So it grouped everything. And so after that, we need to delete all our other points. And, or actually, we could just blast. Use a blast, and we'll delete non-selected, and we'll plug it in here. And we're going to delete everything except for our group, which is group 1. And so now we should only have big trees. Yep. That's all we've got. And we also need to get rid of these. Or actually, no, we could actually probably get rid of the tree rand. Let's see what will happen if we do that. See, there's so many ways we could approach this. Let's actually delete this. And yeah, as a matter of fact, we could get rid of this too. And so it'll just come straight through, and we'll just do what we did right now, where we're grouping all our points and getting rid of everything else. So if we come to our tag here, we've got big trees, and we're bringing in all those extra attributes again. So let's delete all those that we don't need. So that's a lot of stuff. Let's delete it before it comes in. Should be getting deleted here at this stage. Yeah, so I don't know why it's orient, blah, 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 water, bedrock. Yeah, okay, I don't know why it's not deleting it. Update local variables. Should be. Let's just do this all over again. So let's get rid of texture, bedrock, debris, fall off, footprint, height, mask. We want that. Let's get rid of sediment, slope, and water. And that should keep us just what we need, our rotation and that type of stuff, and our variance and whatnot. And so if we come back in here, yeah, we got rid of all, or we didn't. Let's just copy that over, I guess. Let's copy this. We'll just paste it in here. And that deleted all the extra attributes we didn't need. And so if we're down here, what we're left with is just the big tree group. And we have the variance for that group, 0 to 2. And then we have our random selector, which is 1 to 3. And the reason it's 1 to 3 is because we have 1, 2, 3. And so now what'll end up happening is now we could type in our string here. So if we start typing the location of our proxies, which are up here, we come in here and start typing // and if we go through here, you'll notice that we have tree 1 through 3. So we're going to just do tree underscore, and this is where we're going to feed it the attribute that we created, the tree s, the tree selector. So we're going to use the backtick, and we're going to use, since that's an integer, an I attribute and tree underscore s, backtick, and it should have worked. Did I type something in wrong here? Tree, let's see. Okay, I guess I didn't need to tell it was an integer. It already knows. And if we look for our instance file attribute, here we go. You'll notice that we've got tree 3, 1, 3, 2, and all that. And so it's randomly selecting. Well, not randomly. It's based on the rules that we made. It's picking one of these 3 trees to place on our points. So now if we basically rebuild this, and let's just copy paste it. It's probably faster to just do that. And we come in here, and we'll just delete this also, and we'll paste it. Now all we got to do is edit this so that it works with our bush. And so we're going to group, this time instead of big trees like we had earlier, we're going to group based on the tag bushes. Let's see. I think it's bushes or bush. Why is it not here? Big trees. That's strange. Is it not hooked into the right spot? Yep, hooked into out. Tag big trees. We're missing our bushes. Let's see if okay, for some reason one of these is disabling our bushes tag, which is weird. So I'm gonna just delete this. We don't need to deal with it. And just to make sure we're still getting our bushes tag in here. Yeah, okay. And no, we're missing it here. That's strange. Let's activate that. Let's cut oh, that's why. It was connecting way up here. I thought it was connected here, but it just was behind these nodes. Okay, let's do that again. And yeah, there we go. Now we've got it. Okay, so come back in here, and our grouping, instead of big trees, we want bushes. So we'll make this bushes. And once we blast everything away, we'll end up with just bushes. And once again, we have our variant 0 to 1. And since there's only 0 to 1 on our tree selector, that we created up here. We want to, let's rename this to bush selector, since it's bushes, not trees. And for the randomized, we don't want 1 to 3, we just want 1 to 2, because our we only have 2 bushes. So if we check our, and I don't know why it's still called tree S since we got rid of that. Oh no, this is why. So we got to call this bush S. And now if we look for our bush S right here, our bush selector, we have 1 and 2. And so we should have mostly 1s and a couple of 2s. Right now it looks like it's half and half, which is... Oh, actually, no, this doesn't matter. The selector doesn't matter. What's actually putting them in their location is the variant, which we're using, I believe. Let's see here. Scatter on points. And actually, no. This isn't. This is just giving us a 50-50 variant scattering. We don't actually want that. We want, and actually for tree here, we want bush selector. And so that'll select either bush 2 or bush 1. But the problem is now that they're evenly distributed, when we actually need them to be, if it's variant 0 instance tree 1. So how to fix that? Let's see. Maybe we don't even have to randomize. Actually, the selector will be our variance. So let's actually try that. Let's see what happens. So let's, instead of attribute randomize, we'll use, let's delete, or let's bypass this so we won't delete it. But, and our bush selector, we'll disable that too. Because what we could use is just use these numbers, the variant, to control which bush is placed. So if we type in variant in here, what we should get is our instances will match. Yeah. But the problem is now that it's 0 and variant 0. So what we need is +1. So maybe, let me see. So because this is just using variant and our variants are 0s, there's 2 ways you could do this. You could either change this to 0 and 1, or, which is a little easier, and we could actually delete these. We don't need these. I overcomplicated things. The magic was in trying to just separate everything with the group, with the tag group. And actually here what we could do is, since we're starting at 1, you could just add +1. And what that'll do is treat, and actually, oops, we need it to be bush. And so it'll be bush 1 for variant 0. So if we, let's just hide all the other ones. So if you look at this, variant 0 is, this is normally, this would give us a 0, but we put +1, so it's going to pick bush 1. And then variant 1 will give us bush 2. So that'll work. And so if we come up here now, and let's actually do the same thing. Let's get rid of our tree selector attribute. We don't need this, or the randomize. And what we'll end up using is we'll use our variant. So attribute variant +1, and that'll give us tree 1 for variant 0. And so if you guys want to see, let's just pull up the code a little bigger so you guys can see it. That's what's going on here. So we're using instance file with the string that's pointing to go out of the node and go out to our object level. Select tree underscore, and then backtick at variant, because our variant is what's giving us our 0s and 1s to tell it which tree to pick. And we're just adding +1 because we're not starting at 0, we're starting at 1, 2, 3 instead of 0, 1, 2. And so that's why there's a +1. And our expression for grouping, just so you guys could see, and I'll just call this our grouping group expression is that. And so that's S, which is string, our tag, which was our attribute tag, and the name big trees. And that let us group it into trees, for example. And this is our instance file attribute, or string, I guess. And that way, and this is how we're telling it to pick which tree based on our variant attribute. And then these I'll just call proxy vex instance file. And I'll give you guys this so you can see the code and stuff. And yeah, let's test this out. So this should work. What should happen is, and we actually need to add the Redshift object properties. So object, and under instancing, make sure everything's, you know, how it should be. It should be fine by default. And we'll turn on full point instancing. And so if everything is correct, which I think it is, and so I'll just say this is our out, this is our vex proxy instance file. So this will be on its own, so you guys could see this. And I'll actually let me put this behind it. So you guys could see what's going on here. Vex method, instance file. And the other method will be this method, obviously, which is the and let me move it to the side. Instance node method, instance proxy node method, and I'll just do that. Yeah, whatever. And so this is this method, and this should instance all these trees, and it should work just fine. So let's save this, and let's fire up a render and see what happens. It might work, might not. We'll know in a second. It should work, but yeah, as you can see, it can be a little easy to overcomplicate things in Houdini. If, you know, I was trying to make a different setup earlier, and then I realized, oh, I could just get rid of a couple attributes and just group them based on their tag, and that made things easier. So let's I'm gonna pause this and wait for it to start rendering, and then we'll see if it lines up with our Vex method, which it should. So I'll be right back. And so another mistake, guys. See, because earlier we were making instance files. Right now we're referencing the proxies in our scene, and I actually forgot to change this from instance file to instance. So my mistake. Because instance file is when you're referencing to proxies out of your scene. So as you can see now, they're scattered around as we expect. So yeah, you keep that in mind, guys. Instance is for referencing to objects in your scene. Instance file is to reference to objects on your hard drive that aren't actually in your Houdini scene. So something to keep in mind. So yeah, I'm gonna restart the render here, and if everything goes well from the viewport look, it should be fine. So give this a second, guys. I'll be back. Alright, guys, so I'm back. So yeah, we finished our render here, and actually let me increase the gamma to match the previous one I made. And so if we look at this, this is using the instance method referencing these proxies, and this render right here and let's actually disable always on top. Uncheck that. And then this render is using the Vex method, and as you can see, they line up exactly 1-to-1. And if I were to render just using packed primitives, same thing would happen. And so yeah, so I showed you guys 3 ways of doing this. So you could use the packed primitive method, the easiest. You could use the instance or instance file method using nodes, which is this method here, where you delete attributes and you group the tag, and then you get rid of all the other points and stuff, and then you instance on them using the variant, which is, I think, the second easiest way, because you guys should already, if you've seen my other instancing tutorials, you already know how to do this. The only thing that's new is the string tag equals big trees, and all this is just saying group tag, group the attribute tag if it says exactly this, big trees, or whatever you guys are going to choose, for your project. And so this is the second easiest way to do it if you don't know Vex or you don't want to try to learn any of that stuff. And then the more advanced method is down here, which uses Vex. And so this method basically does what all the other nodes were doing in just a couple lines of code. And I'm actually working on a little HDA, a Houdini digital asset, that will make this a little easier. It's not ready yet, but I'm making it so that you could just add slots, kind of like a material. So if we type material, where you could just click this and add however many objects you want, and then you're just going to select them, or type in $hip, whatever, right, wherever your proxy is, and then it'll automatically instance them. And so that's not ready yet. When it's done, I'll probably upload it and make a little video explaining how it works and share it with you guys. But for now, you guys could use at least my frustum point cull, and this will delete points that are outside of the camera, which is pretty useful. So yeah, that about covers the new scattering tools and different methods of scattering using packed primitives, proxies, both using nodes or Vex. And so this is a little more advanced, but hopefully you guys learned some cool stuff, and you guys all learned how the hierarchy system works and what the parameters can do, and so how you can control the percentage and all that stuff of what gets scattered where. And so yeah, I think we got some pretty nice results with this. I might end up working on it a little bit more on my own, maybe just adding different trees and bushes. Right now they're still very similar, so maybe I'll add a little more variety to it, and I'll probably just end up using the Vex and just copy pasting and changing the names, since that's easier. And so this is one of those situations where if you know how to type this up, you'll save a lot of time instead of having to use nodes, and you can just copy paste lines of code and edit what needs to be edited. So yeah, so hopefully you guys learned some cool stuff, some new techniques, and I look forward to seeing whatever you guys work on. I think for next month I'll cover the cloud shading, or making our own custom trees based on some reference photos or something. And so we'll learn how to build a tree from scratch using SpeedTree. So yeah, thanks again for all the support, guys. I really appreciate it, and I look forward to seeing any cool stuff you guys make. If you have any questions, just send me a message on Patreon or on Facebook if you're in the Facebook group, or just ask in the Redshift forums, and I'm sure someone can help you guys out. Thanks again, and have a good one.